Imagine waking up one morning to an emergency broadcast echoing across every device on Earth. The sun is now 50% closer. Extreme solar radiation detected. Seek shelter immediately. At first, it sounds impossible. Something like this shouldn't happen even in science fiction. But within minutes, the truth becomes horrifyingly clear. The sky is no longer blue. It burns with a blinding white gold intensity, as if someone turned the brightness of the sun up to maximum. Shadows sharpen into knife edged streaks. Surfaces heat so rapidly that roads begin to soften. Car roofs become hot enough to burn skin. And the temperature? It rockets upward. Not by a few degrees, but by tens of degrees in a matter of hours. Forests erupt into spontaneous wildfires without a single spark. The oceans begin a violent surge of evaporation, sending towering plumes of steam into the atmosphere. Air conditioning units fail as the power grid collapses under unprecedented demand. People rush into basements, underground stations, anywhere away from the scorching new world above. Mike 5. This is just the beginning. Invisible to the naked eye, the sun's intensified gravity starts pulling Earth into a destabilized orbit. Radiation levels spike to deadly extremes. Satellites fail, electronics glitch, weather patterns collapse into chaos. Within 24 hours, humanity realizes something chilling. Earth was never designed to survive this close to the sun. If our home planet had shifted inward by just a little, life here might still have adjusted. But half the distance? That's an entirely different universe. One where the rules of nature rewrite themselves in real time. Please like this video, subscribe to the channel, and comment your question below. So what exactly does it mean for Earth to be 50% closer to the sun? To understand the scale of this shift, imagine dragging our entire planet from its comfortable orbit 150 million kilometers away down to just 100 million kilometers. This isn't a small adjustment. It's like moving from the safe warmth of a campfire directly into the flames. Scientists already know that even slight variations in Earth's orbit can dramatically change global temperatures over thousands of years, but a 50% reduction in distance, that's a transformation so extreme it would turn our world into something unrecognizable. At this new orbit, Earth would receive more than double the solar energy it gets today. Every ecosystem, every climate zone, every living organism is suddenly pushed far beyond its survival limits. Meanwhile, the sun's gravitational influence becomes significantly stronger, altering everything from our orbital speed to the shape of our year. But this video isn't just about extreme heat, it's about a complete planetary breakdown. We'll explore how oceans, weather systems, the atmosphere, and even the planet's crust respond to this impossible scenario. We'll look at the chain reactions triggered by the sun's increased radiation, and we'll uncover whether anything at all could survive under these new cosmic conditions. Because once Earth moves closer, the world doesn't just get hotter, it becomes an alien planet. The very first and most immediate consequence of Earth moving 50% closer to the sun is a catastrophic increase in temperature and radiation, far beyond anything our planet has experienced in its 4.5 billion year history. At 100 million kilometers from the sun, Earth would receive more than 2.3 times the solar energy it gets today. That means global temperatures would not simply rise, they would skyrocket. Many regions would jump past 70 case digital 158 100 on their attack hazard. Many regions would jump past 70 Kulturkarnan, who is destined the Taklimin point media. That in 100 million kilometers from the sun, Earth would receive more than 2.3 times the solar energy it gets today. That means global temperatures would not simply rise, they would skyrocket. Many regions would jump past 70 Kelvin to 58 to 50 within days. This isn't just too hot to live, it's hot enough to kill within minutes without shelter. And yet, the heat is only half the horror. Because with the sun so much closer, its ultraviolet radiation, X rays, and high energy particles become exponentially more intense. Our ozone layer, already fragile, would be overwhelmed and stripped away in many regions. The atmosphere would flood with DNA destroying radiation levels similar to those on Mars or Mercury. Plants would begin to die almost immediately, especially in equatorial zones. Their photosynthetic systems cannot withstand such intense sunlight. The Amazon rainforest, the Congo Basin, Southeast Asia, these massive green lungs of Earth would ignite in a series of uncontrollable firestorms. As plant life collapses, oxygen production would plummet. Meanwhile, carbon dioxide from mass burn-offs would rise sharply, creating a vicious feedback loop. More heat, more fires, more CO2 one scene, even more heat. But the oceans face an even more dramatic fate. Water has a high heat capacity, but even the oceans cannot absorb this much extra energy. The upper layers would warm rapidly, killing marine life and triggering algae die-offs. Soon, evaporation rates would explode, filling the atmosphere with colossal amounts of water vapor, the strongest greenhouse gas known to science. This would thicken the atmosphere into a heavy, humid, steam filled blanket, trapping heat the same way Venus's toxic clouds do. And suddenly, Earth's climate begins heading toward a runaway greenhouse effect. What starts as an increase in sunlight quickly transforms into a global thermal trap, spiraling far beyond humanity's control. As temperatures surge and radiation floods the surface, Earth enters a second, even more destructive phase: atmospheric and environmental chain reaction. With the sun now dominating the sky at 50% closer, the upper atmosphere begins to heat unevenly. This causes rapid expansion of air at higher altitudes, while the lower atmosphere becomes overloaded with steam and smoke. The result is the collapse of familiar weather patterns and the birth of entirely new, violent ones. Monsoon systems break apart. Jet streams dissolve. Storm cells grow into megastructures. Imagine hurricanes so gigantic they cover entire continents, powered not by ocean heat alone, but by the immense energy now pouring directly from the sun. These superstorms would generate winds over 600 kilometers 30-70 miles per year and rainfall so intense it feels like standing beneath a waterfall. But the rain wouldn't cool the planet. It would flash evaporate on contact with the scorching surface, returning to the sky as more steam and amplifying the greenhouse effect. Meanwhile, the ice caps melt at terrifying speed. In just weeks, Greenland and Antarctica would lose massive chunks of ice. Sea levels would rise rapidly, but even this is only temporary. As temperatures continue climbing, oceans begin to side boil in slow motion. Side not violently, but steadily, like a pot left on high heat. Coastlines disappear beneath rising seas, then re-emerge as dried, cracked salt plains as the water transitions from liquid to vapor. Mountains. Major cities, New York, Karachi, Tokyo, Sydney, Rio, drown, then roast. And then another, darker consequence appears. The atmosphere itself begins leaking into space. The sun's increased solar wind, now far stronger at this distance, strips away gas molecules at an accelerated rate. Earth's magnetic field can't deflect all of it. Over years, the atmosphere thins, losing oxygen and nitrogen while becoming saturated with dense water vapor and carbon dioxide. Humanity faces an impossible combination: a suffocating greenhouse on the surface and a thinning sky above. The planet is being cooked from the inside and eroded from the outside simultaneously. Over time, Earth transforms from a once blue oasis into a world that more closely resembles a young Venus, an oven-like planet trapped beneath a superheated sky. The long-term consequences of being 50% closer to the sun spiral far beyond heat and storms. They reshape the very geology, chemistry, and stability of the planet. As oceans evaporate, the atmosphere grows thicker and heavier, packing itself with water vapor and carbon dioxide. This immense pressure acts like an insulating lid, trapping even more heat. Surface temperatures soar past 120 DT 248 misirade to 1 Sorshal. Fans pine to time so much for Kai. As oceans evaporate, the atmosphere grows thicker and heavier, packing itself with water vapor and carbon dioxide. This immense pressure acts like an insulating lid, trapping even more heat. Surface temperatures soar past 120 DT 248 misirade to 1 Sorshal. Fans pine to time so much for Kai. With the weight of the thickened atmosphere pressing down, the crust begins to respond. Volcanoes become more violent. Earthquakes intensify. Tectonic plates behave unpredictably. Extra heat seeps deep into the mantle, increasing magma production and destabilizing fault lines. Regions like the Pacific Ring of Fire would erupt in continuous volcanic activity, spewing sulfur dioxide and ash, though much of it would rapidly convert into toxic compounds under the intense sunlight. The sky wouldn't darken. Instead, it would take on a harsh, yellow-white glare. Meanwhile, any remaining life retreats underground. Subterranean ecosystems might cling to existence for a while. Fungi, bacteria, and tiny organisms adapted to darkness and heat. But as temperatures continue to rise from above and geothermal energy increases from below, the habitable zone beneath Earth's surface shrinks until there is nothing left. In a few hundred years, Earth settles into a new equilibrium. A superheated desert planet with no surface water, a crushing, steam-laden atmosphere, and an environment so hostile that even robotic probes would struggle to operate for long. The continents bleach under constant solar assault, metals corrode instantly, no clouds form. Instead, the sky becomes a permanent, blinding haze. Earth's once vibrant ecosystems become a memory, its blue oceans replaced by shimmering salt plains and cracked basins. Humanity, if it survived at all, would now exist only in massive underground or off-world shelters, watching from deep beneath the crust as their home becomes a world they can never return to. In the end, moving Earth 50% closer to the Sun creates a chain reaction so violent, so absolute, that our planet undergoes a complete transformation. What starts as a sudden surge in sunlight quickly becomes a catastrophic reshaping of the atmosphere, the oceans, and the very geology beneath our feet. The initial increase in solar energy triggers deadly heat waves, intense radiation, and a collapse of plant life. Oceans warm, then evaporate, filling the atmosphere with water vapor that traps even more heat. Storms evolve into unimaginable superstructures, ice caps melt in record time, and coastlines first drown, then evaporate into barren salt flats. As the atmosphere thickens from below and erodes from above, Earth spirals into a runaway greenhouse effect. Over the long term, tectonic activity intensifies, volcanic eruptions become constant, and the world stabilizes into a harsh Venus like state. Blistering temperatures, a suffocating sky, and a dry, lifeless surface. Humanity's only hope in such a scenario would be underground habitats or off world colonies, watching their home planet evolve into an unrecognizable alien world. A world where oceans no longer exist, where the sky is a blinding haze, and where the surface is too hot for any known life to survive. This scenario reminds us just how fragile Earth's orbit is. Life depends on a delicate balance, a cosmic sweet spot, where conditions are just right. Shift that balance even slightly, and the world changes. Shift it massively, and the world ends. In the vastness of space, our survival hangs on precision.